Today is the 7th of March 2024, and would like to look at trigonometry, the introduction. Okay, I've shown you most all of these formulas, but because I'm dealing with it as a topic, I'll remind you, and then hopefully our next video I'll bring in a lot of questions. Okay, we've been looking at recurring and terminating fractions and decimals. Okay, and we've done 2 videos on that. We've done look at some interesting examples. I've shown you other ways of changing recurring decimals into fraction, which I haven't done in the other videos. I've done other things. I even solved a higher paper on that. I think it was a calculator paper. If it is in a calculator paper, it's easy. But in the non-calculator paper, you might be asking, because you're working under time, you might be asking, how would I know? So that was the purpose of these 2 videos. Okay, now before I start today's video, thank you to all my subscribers. Thank you so much. Okay, please, if you haven't done so already, I'll really appreciate it if you subscribe, share, and like, and follow our platform. Okay, and please, if the account is not yours, ask permission. It's just nice to do the right thing. Really, I find it good. Okay, if it's not yours and somebody lets you watch the video on their account, they won't be there every time doing the same thing for you over and over again. So just ask them, how do I open my account? And they will show you. Maybe go with them with your phone. Let them show you. It will just take some few minutes, and then you have your account. You subscribe, and then when we upload the video, you'll be able to get your own straight into your platform. Okay, in the comment section, I normally write, please follow my notes/scripts. Okay, this is very important. For instance, this is 2 times 3. Okay, even if you hear 3 times 2, it will end up being 6. Okay, but assuming you had 7 times 3, okay, assuming I said that, or I say a prime factors times 3, please go by 2 times 3. Okay, please. Beware of scammers. Okay, we'll never stop about talking about this as long as the social platform and the internet exists. People are scamming. 10 years ago, they were not this wild, but now they have developed sophisticated. They will use your email, use anything. Okay, take people's things, create accounts, and what do they want? Mainly money. So if somebody enters your inbox, send your friend request, enters your inbox, or can I have some donation on behalf of this platform? Say no, block them. Simple. I'm not asking for donation on this platform, okay? So don't be scammed. Some people are watching the video and somebody asked me if I could do a platform for A levels, that is between 16 to 18-year-old. Okay, I don't mind doing that. Even with what I'm doing now, I didn't know I'll go this far. Okay, I thought maybe after 2 weeks I might get bored. Okay, because it takes a lot of time. Yeah, and I'm not able to go maximum of 40 minutes. Okay, because at times by the time I get to 30 minutes, I'm gasping for air. Okay, sorry to say that I don't want to talk a lot about my health here. Okay, but as long as you are happy with what I'm doing and it's going to help somebody, okay, everybody needs a Gcse, okay, where I am, to get maybe an apprenticeship, an access course, or even go to uni. Okay, so some people have everything but they can't even do an A level, an access course, or an apprenticeship, okay, because of the mindset they have about maths. Okay, so that was what encouraged me to to start sharing some of these things. Okay, so that you can see how easy it can be to pass an Gcse maths. And then if you are doing A levels, trust me, you might have got B and above. So you are really, really good. Okay, if you have A level exams in the first few months, it's even late already. So even if I put any material out there, you have a couple of months really. But if it's next year, maybe by September, I would have done a lot of things with the Gcse platform, and then maybe I'll just be doing questions and stuff, past papers, and uploading. So there I can start looking at the topics and then solving more questions with you. Okay, so please, if you are in year 13 and you are going to do A level math, you are good. Believe in yourself. Okay, so but if you're in year 12, maybe up by September or maybe in the summer, I will be able to start uploading. I'll start from the basic, like I started with the Gcse, and then gradually build it on, okay, for you to but I hope I'll be able to do that. Okay, it's not like I'm promising, but I hope I can be able to help you on that. Okay, so I've written it down and I'll start looking. But if you're in grade 13, ask your teacher, what books should I start learning with? Ask them for past papers. Solve one maybe at a time. Go, and if you don't understand, go to them, let them show you and explain to you. Okay, because you can also just do well in that as well. If you did it Gcse, you can also do it at A levels. Okay, so that is where I'll say about that. Okay, but for now, I just want to concentrate with the Gcse platform and make sure that I can encourage and help some people get at least the A star, with the A star to the C grade that they need, so that they can move on to the next stage. Okay, so I hope you understand that. Okay, recap. Last video we've done 2 videos on recurring and terminating decimals and fractions. Okay, so how can you look at the fraction, look at the denominator, and see whether it will recur or terminate? Okay, and then how you can change a recurring decimal into a fraction, and how you can use the long division method, which we have done earlier, to get to do your fraction work. Okay, and change a fraction into a decimal. I hope I said it right there. Okay. Look at the earlier video, look at the last 2 videos. Okay, I've done a lot of examples. I still have more past papers on those. So what I'll do is I'll bring them into the starter, because there's no point doing 5 videos on it. Okay, because you know those are a little basic even for the foundation student. So I'm going to leave it there, and then I'll use some of the starters to give you more of those examples. Okay, now today's starter is about recurring fractions and decimals. So the first example I have here is 5/6. Okay, this is recurring because if you look at the denominator, okay, even before knowing that it's 0.83333, assuming it's a calculator paper, just by looking at the prime factors, I have 2 times 3. Okay, the fact that there is a 3, okay, there should be 1 prime factor. Okay, the fact that these 3 shows means that it will reoccur. It will recur. Okay, so it will be 0.838383 or 0.83333. Okay, so that is it. So here this will reoccur. Okay, and that is the decimal form. Now 7/8. Okay, if you look at the denominator, it's 2 times 2 times 2. All of it is 2. If it's the prime factors are only 2 and 5, or 2, only 2, or only 5, okay, it will terminate. But immediately you have other prime factors involved, like 3 and 7 and 11, it is going to recur. Okay, so 7/8, if you use the calculator or the long division method, it terminates. 9/10 here, denominator here 2 times 5, these are the prime factors, so it's either 2 or 5. Okay, so I know it will terminate. And even if I shift the decimal, it's 0.9 without even using the calculator, because it's 9 divided by 10. So all I have to write is a 9. 10 is 10. I move the decimal one place to the left, so I have 0.9. Even without the calculator, this you should have it on your flashcard already. Okay, because there was a lesson where we had to do all some of like 1/4, 3/4, half, and I introduced the flashcard and I asked you to write them down. Okay. Now today we want to look at trigonometry. Okay. We've done this several times. We've done 5 videos on Pythagoras, which is trigonometry. Okay. It's part of trigonometry, but because Pythagoras is like a big thing in math, I did it under the topic of Pythagoras. With Pythagoras, you need a right angle, okay, triangle. So you need a triangle like this, okay. You have side AB, and then you have the hypotenuse here, the long side here. So to find any missing side, use a squared, okay, plus b squared. A squared plus b squared will be equal to c squared. So if you know c and b, you can find a. So we've done 5 videos. Go back and watch it and make sure you understand. And I've used Pythagoras theorem to solve some beautiful questions in a higher paper. Okay, so and then in the foundation paper. So go back and look at it. This is also SOHCAHTOA, which I have said to you, okay, where the so is opposite over hypotenuse. So that's your hypotenuse. If the angle is there, I need you to follow my notes now. That will be the opposite length. If the angle is here, that will be the opposite length. That is 90 and is facing the hypotenuse always. Okay. So assuming you have a right angle triangle and you know an angle, okay, you can find that angle. For instance, if the angle is here, okay, you can find the sine of the angle by using, if you know the opposite A over the hypotenuse. So that's why you use sine x, sine of the angle, if you know the opposite of at the hypotenuse length. Okay. If you have the angle here and you know the adjacent, that is the adjacent part, and you know the hypotenuse, then you can use cos of the angle, which is equal to the adjacent over the hypotenuse. Okay. And then whatever you get, you find the cos inverse, which will give you the angle. Or you know the angle, so you have cos s, then you can find, you want to find the hypotenuse, and you know the adjacent, then you can use this formula. Tan of x, okay, here again is the opposite over the adjacent. So just by knowing O is opposite, A is adjacent, H is the hypotenuse. You can always create this formula in the exam if you remember SOHCAHTOA, okay? So the tangent of this angle here is the opposite angle A, the opposite length over the adjacent length B, that one. Okay, so if you know an angle and you know the opposite and the hypotenuse, then you go for sine. If you know the adjacent and the hypotenuse, you go for cos. If you know the opposite and the adjacent, then you go for the hypotenuse. You go for tan, okay, to find the angle, or you know the angle, you know the opposite, okay, and then you want to find the adjacent, you go for tan. Okay, these are things, the more you solve, the more you understand. Now, so all this, you have it on your flashcard. If you've not written it down, write it down, so that when you are write it down somewhere, maybe in your notebook, in your flashcard, so when you are solving questions, you don't have to open and look for it, etc. You just have your flashcard or your small notebook, open it topic by topic, and get the equation out. Okay, that is the only way it can stick. That is how some of us will learn. Okay, if you want to always Google solve in the exam, you wouldn't have your phone. So what do? If you Google it, it gives it to you. But what if in the exam you don't have it and you can't remember it? What do? You are stuck. Okay, and even if in the exam they gave you all those formulas and you have to go through, it's another 1 or 2 minutes you are wasting, which you should be using to think about the question and solving the equation, so that you don't rush and get it wrong. Okay, because if you are writing an exam and you are relaxed about it, the chances is that you are going to get more marks. But if you are nervous and you are looking here and there, looking distracted, looking to see what other people are doing, looking for formulas, then you are not going to you'll be very distracted. So at the end of the day, you might not get what you want. Okay, so that is the use of the flashcard, to help you use these formulas as often as you can, so that it sticks. Okay, so when you go to the exam, as you need it, you just reproduce it. Now, to find the angle x, you use the sine inverse. So opposite over the hypotenuse. So that means you know you have an angle, you know the opposite, you know the hypotenuse, you divide it, you find the sine inverse on your calculator. Okay, these are things that will come in the calculator paper. The cos inverse as well. You know the adjacent, you know the hypotenuse. So you divide the adjacent over the hypotenuse. You use your calculator, you find the cos inverse. Okay, so that is where you press your second function and you press the cos, and then it will give you the angle. If you do it wrong, it will tell you, because my calculator, if I press something, it's an angle question, it gives me the angle. So if it's a calculator work, Now, when the triangle is not right angle, that is where the sine rule and the cosine rule comes in, which we've used to solve questions, okay? But all these are under trigonometry, okay? So now you have this one, okay? It's not a right angle triangle, okay? So to find a length, if I know A, okay, and then A and B, okay, and the angle opposite A, B is that one, okay. So I can do A sine A equals B sine B. Equate them together, find sine A and find A, okay. This is A over sine A. So if you have involving A and C, you can equate A over sine A equals C over sine C. Now, if you flip it around, it's also true. So sine A over A equals sine B over B equals sine C over C. So even if you use it in this form or you use it in that form, it's still the same. So as I said here, if you have 1 over 2 equals x over y, and you flip it upside down, both sides, not just one, 2 over 1 should be equal to 1 over x. I spoke about this in one of the higher questions, okay? So take note of that. So you can use the sine rule in this form or in that form. Now, the cosine rule. You know two sides, okay, and it's still no right angle triangle. So to find the side, so you find the side A here, it will be B squared plus C squared minus 2BC cos A. Immediately the angle at A here becomes 90. Then all this becomes 0 because cos of 90 will be 0. Okay. So then you go back again to Pythagoras. But assuming this is not a right angle triangle, okay, then you need 2BC cos of the angle here. So even if it's 89 degrees, you have to find the cos of 89. Subtract 2BC cos of 89. And then you have B squared plus C squared. Remember A squared, so you need the angle involved should be cos A, that angle, okay. So if it's C squared, then you are going to have A squared plus B squared minus 2AB cos C squared, okay. So whatever is, if it's A squared, you need to go for cos A. B squared cos B, C squared cos C. I hope I'm clear on that. I've said this in a subsequent video. So to find the angle cos A, so B squared plus C squared, you move A to this side over A, divide by 2BC there. So if you make cos A the subject, this is what you get, okay. So you can decide to make the cos of the angle the subject and then substitute your B's and the C's and the A. Okay. I think I have learned this one, so I can always make that the subject, because if you're making it a subject and you make it, you get you get a wrong subject, then it means that you are going to get the answer wrong. But if you put the figures directly into the cosine rule, you are still going to break it down to get cos A, and then you find the rest on the calculator. Okay. Now let's quickly look at an example before we go away. So I've brought a simple example which the foundation students should understand. Okay, this is a right angle triangle. Okay, so now we have the opposite. I'm going to do the opposite over the hypotenuse. So I have a squared equals 5 squared plus a. Okay. Now, so a squared will be a squared. 5 squared goes to the other side. So we have a squared minus 5 squared. A squared is 64. 5 squared is 25. 64 minus 25 will give us 29. A squared equals 39 then. A will be plus and minus square root of 39, which will give us 6.2 to 1 decimal place. We choose the plus because it's length and our unit is centimeters. Now, assuming this is not a right angle triangle, okay, let's assume this is not 90 degrees. So here, to find x, okay, I need to opposite over the hypotenuse. That is, if this is not a right angle triangle. Okay. No, this is a right angle triangle, sorry. Because SOHCAHTOA has to do with right angle triangles. Okay. So sine of x opposite 5 divided by 8. So 5 over 8 will give me 0.625, because the denominator, look at it, 2 times 2 times 2, so it's going to terminate. To find x, the angle, it will be the sine inverse of 0.625. Okay. So if you do that correctly on the calculator, you get 38.7 degrees. Okay. So again, the SOHCAHTOA here involves the opposite over the hypotenuse. It involves the right angle triangle. Okay, there. Assuming it didn't involve the right angle triangle, then I couldn't do that. So this example here, the right angle triangle, we found the A, and we used and then we use the opposite and the hypotenuse to find the sine inverse, to find the angle x there. Okay, the example I've just brought. Please subscribe, share, like, follow. Okay, take care of yourself online. Okay. Thank you for watching today's video, and I'll see you in the next.